Hi, this is Prof. Mac, and I'm going to be going over Assessment 9-2A on page 482. This is number 1 and letter A. So what we're going to do is we're just going to read through the problem first. The problem for 1A reads, a box contains 3 white balls and 2 black balls. A ball is drawn at random from the box and not replaced. Then a second ball is drawn from the box. Draw a tree diagram for this experiment and find the probability of the event that the 2 balls are of different color. So there's a number of things that we're being asked to do. First off, we're going to see that this problem has a system of balls that you have to pull out of a bag or have to randomly select 2 balls. And the first thing we should probably do is just kind of keep track of the different types of outcomes we have. So we have a white ball outcome, and there are 3 possible white balls, and there are 2 black balls. So we have a white ball and a black ball outcome. There are 3 white balls and 2 black balls. Okay, the other thing that we should see is that this is multi-staged. And the reason why it's multi-staged is because you have a first step where you draw a ball, and then you have a second step where you draw a ball. Whenever something's multi-staged, then you have to ask yourself, is it dependent or independent? In this situation, there is no replacement, meaning the ball is not put back after the first time a ball is pulled. And so therefore it is dependent, meaning that the second stage is dependent on the first stage. Alright, so now we got most of our information there. Finally, we're asked to do 2 things. The first thing is we need to do a tree diagram. And the second thing we need to do is we need to state the probability of balls different in color. Alright, so the first thing I'm going to do is I'm just going to start setting up my tree diagram. Now, you actually can do this a number of ways, but I actually like to do it where I draw it all out, and then later I could then combine commonalities. So I'm going to just draw out my first ball, which is a white ball. I'm going to have 5 total. And if I drew this particular white ball, I'd have a 1 in 5 chance of getting it. And then, if I then drew another ball without replacement, I would have an option of 2 white balls, because remember I picked one up and I'm not putting it back. That's this one right here. So I have an option of 2 white balls and 2 black balls. So that second stage is actually a 1 in 4 chance for each of those. Now what I mean by combining is I actually could combine these 2 right here, and I could change those into a half, and these as a half, rather than having fourths. You'll also see that I could do it on this side in just a little bit here as well. So the next one I'm going to do is another white ball, because that's now the second of the 2 white balls that I could have gotten. Of the 3 white balls, sorry. If I select that white ball, then I have 4 left in the bag to choose from, 2 of which would be black, and 2, the remaining 2 that would be in the bag that were white. Those also have a 1 in 4 shot each. The next thing I do is I draw another white ball. This is my third of the 3. And so here I go with my 4 balls that are left over. And so I've taken care of all my white balls. Now, what's the chance of me pulling out a black ball? Well, there are 2 black balls. So the first one that I could do, if I got a black ball, the second time I would have 3 white balls in the bag and 1 black ball left over. If I wanted to combine those, I could have just done one line, made it white, and then had a 3/4 chance rather than all 3 of these 1/4 chances. And then the same odds for the second of the two black balls will occur as well. Then remember how I said that that whole combining thing that I've been talking about with this 3/4 and 1/4 here, and a 1/2 and a 1/2 right here. Now if I look at all of these, I also see a 1/5, 1/5, 1/5. That's 3/5 chance of pulling a white ball the first time. And then down here, it's a 1/5, 1/5. That's a 2/5 chance of pulling a black ball the first time. And so you can actually combine these together and start taking those probabilities into account as well. But if you want to just do all of the outcomes listed, that's fine as well. Once we get here, we know that 1/5 times 1/4, this exact thing, this exact white ball and this exact white ball, there would be a 1 in 20th chance, meaning there are 20 different outcomes, and this is one of those 20 outcomes. So what I'm going to do is I'm just going to generate my different outcomes so that I can answer my problem. And if you combine, you'll see that you actually have far fewer of these to draw. And then as I go through here, I'm looking for one of each color as an outcome. It doesn't matter order. It's okay if I have it first or second. I just want to have one of each. So 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. Remember, it's out of 20. And that actually simplifies down to 3 out of 5. So I've done my tree diagram. Now I'm going to write my probability as the probability of balls different in color equals 3/5. And so that's my final answer with the tree diagram used to illustrate. And so that is how I would do 1A.